Hi everyone, and welcome to this video on it's going to be a quick video on how Lipschitz continuity, which is a stricter form of continuity, implies uniform continuity. Before we proceed with the formal proof, let's just sort of say something about or recall what Lipschitz continuity is. So a function, say f, that maps from a space x to some space S is said to be Lipschitz continuous if there exists some beta that's positive, such that for any two values in the domain, which is x, or in that space, the norm of the images, so that's fx naught and fx1, is less than or equal to beta times the difference of the points themselves. So let's go with the proof. Okay, so proof. Okay, so suppose it's going to be sort of a direct proof. Suppose f is Lipschitz continuous. So suppose f is Lipschitz continuous with a Lipschitz constant of beta. Okay, so let epsilon be greater than 0 as normal. It can be any positive number, whether big or small. And let the distance between the 2 points, x0 and x1, which are contained in x, be less than or equal to delta, right? And let's define delta as some positive quantity, where delta is equal to, so epsilon. Epsilon we know is positive by our assumption. And then we know that beta is positive as well by our definition of Lipschitz continuity, right? Then, okay, this is going to be a very straightforward proof. The distance, okay, appealing to the definition of Lipschitz continuity, this norm again is a notion of distance. So the distance between the images, x0 and x1, right, is less than or equal to beta, right? Again, distance of x0, x1, right? But this one, we know, right, is less than delta. The distance of that is less than delta, right? So we now have beta times delta. And this form here is going to be beta times epsilon over 2 beta. So the betas cancel out. So we know that this is going to be equal to epsilon over 2, right? And because that's epsilon over 2, we know that we can conclude that this distance here, right, fx1 is less than epsilon over 2, which is a small number. That's going to be less than epsilon, right? So what we have found out is that the distance between x0 and x1 being less than or equal to delta implies that the distance between the images x0 and x1 is less than epsilon, which, if you recall, which is the definition, right? That's the definition of uniform continuity. So we have proved it quite simply. So that ends our proof. And it implies that Lipschitz continuity implies uniform continuity. So thank you very much for your attention, and I'll see you in the next video. Thank you so much.